Welcome to Malvern Analytical's Applications Lab in the UK. I'm going to show you how to measure the particle size distribution of battery type materials using the Mastersizer 3000. The Mastersizer 3000 is a laser diffraction system that lets us measure particle size distributions from below 100 nanometers up to a few millimeters in size. We've got a range of different dispersion units for different types of samples that let us measure particles as dry powders dispersed into air. We can also disperse dry powders into liquid and measure them as suspensions, or we can look at emulsion samples on the Mastersizer 3000. We're going to focus on measurements in liquid in this demonstration, as that's how most battery materials are measured, especially as the particle size gets finer. If you're also interested in measuring dry powders dispersed into air, then there are other demonstration videos that show this process on YouTube. Right, let's get started and measure the sample. First, I'll show you the equipment that we're going to use. So that's the Mastersizer 3000 with a Hydro MV dispersion unit. So you'll have heard in our fundamentals section that the Mastersizer 3000 uses laser diffraction to measure particle size, and that's a light scattering based technique. You'll also have seen a schematic of the instrument showing you the optical components that we use to make that measurement. So just to bring those two things together, so this is the optical bench. So our laser light source is along the bottom here. We've got some optics to bend that light source around and into the measurement cell. So this is where our particles are going to be, in this case in liquid suspension. So if I just pop out the measurement cell. So you can see we have a window in the measurement cell, and that's where our particles are going to interact with the laser light and then scatter that light. The way we get the particles through the measurement cell is based on the dispersion unit here. So this is the Hydro MV dispersion unit. It has a tank of dispersant, tank into which we add the dispersant, which will be about 120 mils. We've then got stirrers to suspend and circulate the particles, and ultrasound to provide some more dispersion. So once we've got this stirring, then it will feed the sample through the measurement cell and have it passed back to the dispersion unit. So we have our sample recirculating in a nicely dispersed state. What you can see in the measurement cell is the window here. So the particles will be flowing through the measurement cell. They'll interact through the window with the laser light, and then the particles will scatter light over a range of different angles. So if I pop that back in, you can imagine our particles are then scattering light over a range of different angles. So we have detectors along the back of the instrument, along the sides, and some backscatter detectors in order to collect that light scattering over a range of different angles, giving us a wide-ranging particle size measurement. So that should give you an overview of the hardware that we're going to use, and next we'll look at how we prepare the samples. So next I'm going to show you some sample preparation. When we're dispersing a powder into a liquid, first thing we have to do is to choose what liquid we're going to use to disperse the sample. It needs to be clear and free of bubbles and not too viscous, but importantly what it has to do is wet the sample. So the simplest and the cheapest thing to use is water, but you might find that you need to use some surfactants to reduce the surface tension between the water and the sample to help disperse the particles. So the first thing we'll do is a wetting test in a beaker. Testing the dispersant on the sample in a beaker means that if it doesn't wet very well, then we haven't made a mess inside the dispersion unit, which will take a little bit longer to clean. So in this case, we have a sample that's similar to a battery material. It's a silicon carbide sample. So what we're going to do first is to do that wetting test. So I will pop a little bit of sample into our beaker here. And first thing we'll test is just water. So add a little bit of water to that, see how well it disperses. So give it a little bit of a mix around. And you can see it's not too bad. The water's not sitting on top of the powder. but it is sort of clumping together at the sides, so it's not brilliantly dispersed in just water. So what we'll then do is take another sample of our powder, put that in there, and this time we'll use a little bit of surfactant to aid the dispersion. So this is an Igipal solution, and I'll just put a couple of drops of that into the sample, and then we'll do the same, mixing that up to see how well that wets the sample. So you can see from these two, you see one that's kind of just sitting around the edge of the beaker, whereas the other one is spreading out much more evenly, so it shows better dispersion. So in this case, this is the one we're going to measure using a surfactant solution of Igipal in deionized water to measure that one. So that's the first thing I would do whenever we get a new material, is to do a wetting test in a beaker and see what surfactants work best for you. Now, you'll understand the chemistry of your materials much better than I do, and there are also articles that you can use to help you to understand how to disperse powders into liquids. In this lab, we test a lot of different materials, and we've got quite a range of different surfactants and additives made up, so you can just try a few out and see what wets your sample best. So for this silicon carbide sample, similar size to a battery material, we're going to disperse it into water and use some Igipal to wet the sample. Right, so now that we've prepared our sample, we can make the particle size measurement on the Mastersizer. Right, so we're going to measure the silicon carbide material that we've just prepared the dispersion for. I've got the Mastersizer 3000 software open here, and what we're going to do first is just to run it as a manual measurement. That means I can change things as we go along. It also means I've got a bit more time to talk you through what's happening in the measurement. So I'll just start that up here. So you'll see that pops up immediately with the manual measurement settings. So I will call this sample 1 for want of anything better. We can also go through and tell the system what sort of particles we're looking at, what the material is that we're measuring, what dispersant we're measuring in, and also things like how long we want to make the measurement for and how many repeat measurements we want to make. We also give it an idea of what concentration we want to make the measurements at. So we could go into this in a lot more detail, but just as a demonstration, we've set this up to measure the silicon carbide sample. So we'll click OK and get started with the measurement process. So if I press start, the first thing it's going to do is to fill up the dispersion unit. So the Hydro MV is going to fill the tank with water and then make sure it degasses the tank. So there's a certain amount of whirring as it does that. While it's doing that, I'll explain what we can see in this software view here. So we have the laser power. So that's the power of the laser going straight through the empty measurement cell. And then we've got the live light scattering data view. So that's showing us the scattering falling on the detectors from just the water as it's been filled up. What it's doing next is aligning the system. So it will move the detectors at the back of the instrument so that the laser hits the center of that detector. Once it's done that, we'll measure a background signal. So that's essentially just the scattering data from the water as it's being circulated around the dispersion unit. And what we're looking for is to see that we have a nice decreasing signal across the detectors. That tells us that the system's nice and clean. It's essentially our blank measurement, so the scattering from the dispersant before we put any particles in. So we start by measuring that signal. So you'll have seen in the earlier presentations in the fundamental section that we measure with a red light source and a blue light source. So you find it's doing the background first in the red and then in the blue light source. So we take our blank or our background measurement of both light sources, and then it's ready for us to add the sample. So you can see this control on the left has changed to show us what we call obscuration. So that's how much of the laser light's getting blocked out by the sample as we add it. It gives us a good measure of concentration of particles in the measurement cell. So I will grab the sample that we've just prepared. And add a few drops of that in until the concentration is within that nice green region. So we've got enough sample to measure. There we go. So what I'm looking for is to get the obscuration into the green, to see that we've got a nice smooth scattering pattern, it's not too noisy or anything. And then once the concentration's in range, it will start to give us a live particle size distribution. So once I'm ready, we can click measure to start recording that scattering data. So like we did with the background, it's going to do that using a red light source and then the blue, then combine the data together in order to give us a particle size distribution. So we've got the live light scattering data there, the size distribution here, and then it will start to build up a trend of those 5 repeat measurements that I'm making. So we've got the first one in there, and once it's made more measurements, it'll start to build up that trend view. What the manual measurement does is it gives you a bit more control over changing some of the dispersion parameters. So we've got controls for the dispersion unit over here. So looking at how full the water level is, what the stirrer is, whether we want to apply any ultrasound to disperse the sample. So it's there to give you access to all of the different controls you can have for making a measurement in wet dispersion. Primarily used for method development, so you can see what you need to do to your sample to get a good result. So we've made 4 measurements so far. I've set it up to do 5, and you can see the trend is nice and stable. So here are 4 results that we've got so far. It will also give you an average and an RSD over those repeat measurements. So we can see that the RSDs is well below 1% for each of those measurements. So what it's done is it's given us 5 repeat measurements, and then we've got 1 average at the end, so 1 measurement that's an average of those 5. So I'm pretty happy with how stable those results are. So to finish the measurement off, we'll just set it off to clean. So while the system's cleaning, what it does is just to empty the tank and rinse it with fresh dispersant. So the system we have here with the Hydro MV is a fully automated dispersion unit, so it's plumbed in, it's got a drain tube, so it can run a clean sequence without you having to do anything. So that's what it's running through at the moment. It's filling and emptying the tank to rinse out the particles and get the system ready for the next measurement. So what it will do on its final fill is again to run that degassing procedure so that we've not got any bubbles in the measurement for the next test. So once it's finished cleaning, it will come back up to the speed that we set it for in the measurement, and we should see that we get back to the same background signal that we had before. And from that you can tell the system's nice and clean, ready to go for the next measurement. So now that we've made the measurements, let's take a look at the results back in the main software view. So you can see here are 5 repeat measurements, and it's made an average at the end. So this is the records view, so that gives us a view of each of the measurements that we've made. On the right hand side we've got the reports view, so this displays all of the different information about the measurement and the results that we've got. So give us some information about the measurement details, the results, so the DV10, 50 and 90, and the particle size distribution. We've got a series of different types of reports that will display different information for you. So if I click on the data graph and pick one of the records rather than the average, then that will give you the data in the background. So you can check that the system was clean and look to see that we've got a nice, stable scattering pattern. You can also look at the fit to the data. So we haven't really gone into this, but how well the optical model fits the scattering data that we've measured. If you want to know more about that, there's more information in other webinars and demos. We've then got a couple of reports that are there to help you overplot the data. So I can create a trend report, and that will show me that my 5 repeat measurements were nice and stable. There's no real change in the particle size distribution. It'll also give me a table and some averages below, so the average and the relative standard deviations. We've also got a result overlay here, so that will overplot those 5 different size distributions from the repeat measurements. Another thing we can look at over on this side is the data quality report. So that will look at a range of different aspects of the measurement data to make sure that the system's nice and clean. For example, we've put in the right amount of sample, so that's referring to the obscuration. We get a good fit to the data. So it does a range of basic data quality checks so that you can have some confidence in the results that you're producing. So I chose to use silicon carbide sample of that size because it's very similar to battery materials that we've measured in the past. So what I'll do next is to open the measurement file for lithium cobalt oxide, and we can compare the two and have a look at how the lithium cobalt oxide was measured. This lithium cobalt oxide sample has been measured in a very similar way to the silicon carbide that we've just run. So it was dispersed into water using Igipal as a surfactant to aid the wetting. In the file here you can also see that we've done 5 repeat measurements to start with. We've also looked to see what the effect of ultrasound is. So here are our first 5 repeat measurements. We've then measured it with some ultrasound applied to see if it disperses the sample any further. And finally done another set of measurements after the ultrasound's been applied. And you can see here that the ultrasound's not really having any effect on the measurements. There's no change in the state of dispersion throughout that process. So we would stick with the first 5 measurements and set up a very similar measurement to what we've just done with the silicon carbide. So let's compare the results of the lithium cobalt oxide to the silicon carbide sample that we've just measured. And you can do that quite easily in the 3000 software. Once you've got more than one measurement file open, we get an All Files tab over here. So we can just click on that and it will show us all of the results that are currently open. And if you want to make it a bit easier to sort them out, we can drag the file name up there. So we've got everything that's in the battery demo and then all of our lithium cobalt oxide measurements down here. So if I grab the average from the silicon carbide and one of our lithium cobalt oxide measurements, you can see they're very similar in terms of particle size. So that's why I chose that sample for the demo. We don't always have all the right materials in the lab, so that gives us a pretty good analogue to a battery material. That also gives me an opportunity to show you some of the other features in the software. So one of the tools I find really useful is an SOP summary. So here, if I click on that button, it will show me all of the settings that we've used to make each of those measurements. So you can see here we've got record 6 and record 1, and then all of the SOP details, the material properties, etc. When it's most useful is when you're comparing results and you want to see if everything's been measured using the same properties. So I like to grab that and highlight the difference. So it will tell me different sample name, different optical properties, obviously for the lithium cobalt oxide compared to silicon carbide. You can also use this feature if you want to copy and paste your measurement settings into a document. So for example, if you're having to write a report, it gives you a really easy way to report all the measurement settings that you were using for that particular sample. There are a couple more things about how we can report the results that I'd like to show you. So I'll go back to our lithium cobalt oxide measurement file there, drag that file name off. So if you wanted to report a non-standard parameter, for example, we report the dV 10, 50 and 90, the percentiles of the distribution as standard. But if, say, taking a look at this distribution, you wanted to look at the percentage of material that's smaller than 10 micron in size, for example, we can add that quite simply as a custom parameter. So if we go into our column configuration by right-clicking up here, then what I need to do is just type in result, and it will come up with result below. And I can edit that once I've added it to the list. Just move that up there. So I can edit that to say I want the result below 10 micron. And we'll add that to the list on the column. So that's really easy to do. You can quickly configure your result view to have whatever parameters you want in it. If I wanted to search in either of those views, for example, as well, I could look for everything in here that's got more than 70% in the result below 10 micron. So you can use that as a search feature as well. Clear that filter. Once you've got the parameters you want set up on the records view, if you want to take them to another program like Excel to process them further or to put into reports, then you can just drag those records directly into Excel, which will open, and then we can plop that data in there. So that's a really simple way to start exporting the data. There are other ways you can export the data quite simply. So you can take it directly from the reports, where you can say copy as raw data, and again you can paste that directly into Excel. And you can do that with the report parameters. You can also do that with the size distributions. So you can take all of the data that's making up that size distribution and pop that straight into Excel as well. So it's really quite flexible in terms of what you can do with the data once it's been recorded in the Mastersizer. An important thing to note if you've made some measurements and you want to go and change anything is once you've got the records, you can edit the result. So anything to do with the analysis, we can change after the measurement. So if maybe you didn't know what the optical properties were, you could go back in and change those after you've made the measurement. It will retain all of the scattering data, so it can recalculate the result with different parameters. So it's quite a useful feature if you're measuring materials where you're not quite sure about what the optical properties are. So if we change that, say, to 1.75, what you'll see is it will generate a new record. And we can compare that to the one we started with. And because we haven't changed the optical properties very much, you'll see it hasn't made too much difference. One really handy thing you can do once you've set up your method for a new material, once we've got those measurements, is we can just extract a standard operating procedure. So then all of the method parameters and the analysis parameters will be fixed, and we can just run through it, put the sample in, and it will do everything else for us. So I'll show you how to do that now. So once we've made our measurements, I can just click on a record, right click, and extract the SOP. So that will have all of the measurement settings that we've already set up in that manual measurement. It will remember everything. So all we need to do is save that as an SOP. And let's call that battery SOP. Oh, can't type. And then, when we want to run that SOP, all we need to do is pick it from the recent list here, and that will just start running. We can make any amendments to the sample documentation, and then it will take care of all the measurement and analysis settings this time round. You'll see that we no longer have the controls for the dispersion unit because all of that's fixed. All we'll need to do is add the sample in when we get to that stage. So this is very much how you would run the system for routine analysis. So where in the manual measurement we had to click to move it along the measurement process, here it's going to do it automatically. So now we can add some sample in, just dropping it into a similar obscuration to where we were before. Okay, so start measuring that sample. And it will run through those same 5 repeats that we had in the manual measurement. And again, it will build a trend view of those repeat measurements so that we can always check on the stability of the measurement. So once it's finished that second measurement, you'll see that will start to build up the trend again. And this time, once it's finished, it will move directly into the clean sequence. And once the SOP measurement's finished, we can compare the results that we got from the manual measurement to the results we got running the SOP. So I've picked out the 2 averages from those 2 repeats of the same sample. So that shows we've got nice, good, reproducible measurements of that sample. So one more thing I'd like to show you, because it's a commonly asked question when we do these types of demos, is how to clean the measurement cell in the Mastersizer 3000. So first of all, I'll just empty the dispersion unit and then we'll bring the cell across here and show you how to clean it. So just disconnect the tube and pop the cell out, and I'll show you how to clean it over here. So we've got the cell on the bench now. What I'm going to do is show you how to clean the windows in the cell. So I'm going to pop it down on its side, and then I can unlock the measurement cell, turn that round, and we can just split that cell in half. So you can see the insides of the flow path, and that's the bit that we're going to clean. So first thing I'll do is just to rinse it off with some water, just in case there's any particles left behind that might get dragged across the window and maybe scratch it. So just do that. And to the side that's inside the cell as well. There we go. So you might want to do that near a sink. It's easier to film it here. So what I'll do next is to take a bit of a lens tissue and a bit of alcohol and just make sure we remove any grease or anything like that from the windows. So I'm going to wipe across the window with that alcohol impregnated tissue, and then I will take a dry bit of tissue as well and make sure we clean that up. So that's all we need to do for routine cleaning of those cells is to make sure you generally wipe across the cell only in one direction. In case there's any dirt on there, we don't want to just move it around in circles. We want to move the dirt off the window, any grease off with the alcohol, and then I'll just wipe the window with the dry side. Okay, so that's that done, and I can reassemble the cell. So there's a little pin to locate it, make sure we get it in the right position. So pop that in and then just lock the cell in place, and then it's ready to put that back into the instrument. So I'm going to take the cell, put it back into the instrument, slide it in, it will grab it and lock it into position, and then we just need to connect the tubes back up. They're nice and colour coded so you can't get them the wrong way around, and we just secure them in place with those. Okay. And then we can tell the dispersion unit to fill up again, and it'll be ready for the next sample.